Welcome back, Geometry. We are doing a very important section today. Chapter 2, Section 2, Conditional Statements. So pause, try this quiz, and come on back. All right, you should have number 1, the measure of an obtuse angle is less than 90 degrees is false. Number 2 is true. Number 3 is false. The one counter we talked about is the number 2. And number 4 is false. Today we're talking about conditional statements. So the definition of a conditional statement is found in this rule box. So a conditional statement is a statement that can be written in the form if P, then Q. So the part P of a conditional statement that follows the word if is called the hypothesis, right? And the part Q of a conditional statement that usually follows the word then is the conclusion. Hypothesis if P, then Q. By phrasing a conjecture as an if-then statement, you can quickly identify its hypothesis and conclusion. So let's look at some conjectures and see if we can locate the hypothesis and conclusion. If today is Thanksgiving Day, then today is Thursday. Jot down the hypothesis. Today is Thanksgiving Day. And the conclusion, today is Thursday. Did you know that Thanksgiving always falls on a Thursday? So that is a true statement. How about for example 2? A number is a rational number if it is an integer. This has a little different format. We don't see if, then in the order that we're used to seeing them, right? So what is the hypothesis? A number is an integer, right? It was the second part of the statement, if it is an integer. So if it is, then the conclusion is the number is a rational number. Identify the hypothesis and conclusion of a number is divisible by 3 if it is divisible by 6. So the hypothesis then is a number is divisible by 6. Again, we have the hypothesis in the second position of this statement, right? So the conclusion is the number is divisible by 3. When writing math, when writing these conditional statements, in math, you know, we love to write in shorthand, right? So let's see the very varied ways that we could write our conditional statements. We could just write them out if P, then Q, right? If the hypothesis, then the conclusion. It could also be written if P, Q, without the word then. We saw that in one of our examples, right? This is the last two examples we saw in this format. Conclusion, if P. So it's kind of flipped around, right? And finally, we could say P implies Q, or P only if Q. So you may not always see the words if, then, exactly like that, but that doesn't mean you don't have a conditional statement. They may be written this way too. Let's write a conditional statement from the following. So this says an obtuse triangle has exactly one obtuse angle. Can you identify the hypothesis? An obtuse triangle has exactly one obtuse angle. Well, the hypothesis must be an obtuse triangle, right? The conclusion is, if it is an obtuse triangle, then what could you say? It has exactly one obtuse angle. So we take those two statements and put them into our if-then form. If a triangle is obtuse, then it has exactly one obtuse angle. Okay, let's look at this Venn diagram and see if you can make a conditional statement from the following. We see blue jays and we see birds. So the question is, which one of these is the hypothesis and the conclusion? And if you forgot what was on that Venn diagram, that's okay. We can just kind of logically walk through this. The question would be, if it is a bird, then it is a blue jay, or is it, if it is a blue jay, then it is a bird? And after having walked through both scenarios there, you could probably see that if it is a blue jay, right, then it is a bird. So the inner oval ends up being the hypothesis, right? And the outer oval would be then the conclusion. And once again, if you forget that, you can try it both ways, and you'll probably be able to deduce it when you do that. All right, let's write a conditional statement from the sentence, two angles that are complementary are acute. First, which is the hypothesis? Which is the conclusion? Well, the hypothesis would be two angles are complementary, right? And then the conclusion, they are acute. So when you have identified those, the hypothesis and the conclusion, it's very easy then to write the statement, isn't it? If two angles are complementary, then they are acute. The truth value of a statement. You know, sometimes we make a statement and, I mean, it's sitting there, it's a statement, but it's not true, right? Usually we like true statements. We seek the truth, don't we? So conditional statements are true or false. It can be either. So the conditional statement is false when the hypothesis is true, but the conclusion is false, right? If the hypothesis is true and the conclusion is false, we can say that the entire statement is false. This is really important, okay? If the hypothesis was false, that's another story, so we'll see that in a sample. So we would prove that a conditional statement is false with what? Remember my Taekwondo example? With a counter example. Good. So we'll determine if this conditional is true. If it is false, please give a counter example. If this month is August, then next month is September. Can you think of a counter example to this conditional? Well, there isn't a counter example, is there? If this month is August, the next month is September, right? So the hypothesis is, if it's true that this month is August, then the conclusion is also true because September follows August. So this conditional is true. Determine the truth value of this conditional. If two angles are acute, then they are congruent. Can you think of a counter to this conditional? I bet you are thinking of them, and you can use any counter you like, right? If two angles are acute, does that mean they have to be congruent? How about if we have a 30-degree angle, that's acute, and a 40-degree angle? 30 and 40, two angles, are both acute, and yet they are not congruent, right? So, as it says here, you can have acute angles with whichever two measures you choose that are not the same, right? In this case, the hypothesis is true, but the condition is false. This is a false conditional. What is the truth value of this statement? If an even number greater than 2 is prime, then 5 plus 4 equals 8. Okay, what do you think of this hypothesis? If an even number greater than 2 is prime, is the hypothesis true? Is there an even number greater than 2 that is prime? And we talked about that just yesterday. There is not an even number greater than 2 that is prime. So the hypothesis here is false. Isn't that interesting? It's false. And the conclusion happens to also be false, right? But if the hypothesis is false, it doesn't even matter whether the conclusion is true or false. What's very interesting here is if the hypothesis is false, the conditional statement is true because the hypothesis is false. Isn't that interesting? So I'm skipping one slide and going to the statement made on the next. It says that if the hypothesis is false, the conditional statement is true, regardless of the truth value of the conclusion. So when you have a false hypothesis, then anything can happen, and it doesn't even, it is, we could say that the truth value of that statement is true based on, the fact that everything is false if the hypothesis is false. Isn't that interesting? It's really an interesting fact. So it goes back to this one. If an even number is greater than 2 is prime, so if that false thing is, if this is false, then the whole thing may be true. The conclusion may be true or false. It doesn't matter. But the entire truth value of the statement is true because the hypothesis is false. It doesn't have to, the hypothesis and conclusion don't have to make sense when the hypothesis is false. We're not saying that the whole conditional is a true statement. We're just saying that the truth value of that statement when the hypothesis is false is that it is true. Interesting. Okay, let's try this one. Determine if the conditional, if a number is odd, then it is divisible by 3, is true. If false, give a counter. Can you think of an odd number that is not divisible by 3, right? And I'm sure you can think of many. Think of, let's say, 5, right? Is that divisible by 3? No. So the hypothesis is true. The conclusion is false. So this entire conditional is false. The negation of statement P is not P, written as a single wavy line P. The negation of a true statement is false. If we have a true statement and we take its opposite, we're saying it's false, right? And the negation of a false statement is true. So these are called related conditionals. A conditional statement is exactly what we've said. If P, then Q, right? The converse of a conditional would be to switch the Q and the P. Turn the Q, the conclusion, into the hypothesis. So we would say, if Q, then P, which is interesting. The inverse of the conditional is, if not P, then not Q. So it looks like the first statement, the conditional statement, the same order, P, then Q, and yet each of them are their inverse. If not P, then not Q. The contrapositive is really the inverse of the converse. In other words, if not Q, then not P. Okay, so you're going to be asked today to write the converse, inverse, and contrapositive of given conditional statements. So this little diagram is important. You need to know these. Let's write the converse, inverse, and contrapositive of the conditional statement given. Use the science fact to find the truth of each. Okay, whoops. If an animal is an adult insect, then it has 6 legs. So there's your conditional. So the converse of the statement would be to take and switch the hypothesis and conclusion, right? If an animal has 6 legs, then it is an adult insect. No other animals have 6 legs, so the converse statement is true. The inverse is take the original statement and negate it, right? So if an animal is not an adult insect, then it does not have 6 legs. No other animals have 6 legs, so the converse is, or let's see, the inverse is true. This is a typo, okay? The contrapositive is, if an animal does not have 6 legs, then it is not an adult insect, which is also a true statement, all right? So make sure that you really review these and know how to create these sentences. Related conditional statements that have the same truth value are logically equivalent. This is the law of contraposition.